Okay, let's dive right into an incredibly exciting development in AI research that completely changes how we train autonomous mobile agents. Today's explainer is all about a platform called MobieGym. Think of it as basically building a digital matrix for artificial intelligence, allowing it to learn how to use our everyday apps safely and critically at a massive scale. Now, you might be wondering, how do you actually teach an AI to use a smartphone without it, accidentally wiring away your life savings or texting your boss something bizarre? It sounds like a joke, for sure, but this is the very real, super high-stakes bottleneck that researchers face when handing AI the keys to our digital lives. When an AI makes a mistake during training on a real phone, the consequences can be permanent and, honestly, financially disastrous. To break this all down in today's explainer, we'll hit the mobile agent problem, enter MobieGym, look at how the simulator works, dive into answer sheets and benchmarking, check out sim-to-real transfer, and wrap up with the future of AI training. So, Part 1. The mobile agent problem and the heavyweight bottleneck we're currently facing. Let's be real, training an AI on an actual live app right now, it's a total logistical nightmare. The barriers are just baked into how everyday apps work. First off, they're unreadable. Internal states, like your bank balance or order history, are hidden away in proprietary backends and caches. That makes it super hard for an AI evaluator to know if a task truly succeeded just by looking at a screenshot. Second, they're unwritable. You can't easily reset a live app to a specific starting state to run a clean experiment. Third, they're unforkable. You cannot easily clone a live app into hundreds of parallel instances for large-scale training. And finally, like we touched on, there are those irreversible real-world consequences. And you can really see this hardware barrier when we compare standard Android emulators side by side with MobieGym. A standard emulator, that's going to hog about 4.5 to 6 gigabytes of RAM per instance. It takes roughly 78 seconds just to cold start and eats up 20 gigabytes of disk space. Scaling that up for parallel AI training requires massive, super expensive cloud clusters. But MobieGym, it runs right in a browser using only about 400 megabytes of RAM, cold starts in a lightning-fast 3 seconds, and takes up just 50 megabytes. This literally changes the game entirely. Moving on to Part 2. Enter MobieGym, the browser-based matrix. This right here is the aha moment of our explainer. We realized we don't actually need a heavy emulator. We just need an environment that looks and feels totally real to the AI. Inside MobieGym, the AI is operating a fully simulated messaging app, complete with chat history and predictive text. Right next to that, there's a system launcher loaded with interactive widgets and a familiar Android-style status bar. It's completely sandboxed and browser-hosted. The AI genuinely thinks it's tapping a real screen, but it's operating safely inside a lightweight simulation with zero real-world consequences. It's literally a comprehensive ecosystem. MobieGym includes 12 everyday apps that cover major categories of daily use, plus 16 system apps. It features over 400 parameterized task templates, meaning tasks can be randomized to create tens of thousands of totally unique training scenarios. And because the entire state of the phone is configured as a simple, lightweight JSON file, a single commodity server can host hundreds of parallel instances all at once. All right, Part 3, how the simulator works, deconstructing the architecture. Now, what makes all of this possible without those heavy emulators is what's called the composition model. Looking at the architecture, you can see the system dynamically builds the final UI by perfectly combining 3 distinct layers. First, there's world data for large-scale external app data. Next, a runtime overlay manages the active mutable state, the stuff changing as you use the app. Finally, the OS runtime handles core navigation. A rendering engine seamlessly pulls these together, but the absolute key here is that the entire underlying environment, every single chat, order, and intent is explicitly represented as structured JSON data. And because everything under the hood is just text-based JSON data, researchers can run this highly efficient 4-step loop. First, they instantiate a task using a template. Second, they fork that identical starting state into dozens of parallel rollouts. Third, when the AI finishes, they can verify the outcome perfectly by just comparing the initial JSON state to the final JSON state. And fourth, they use that state difference to produce definitive success signals in training rewards. This creates a totally verifiable loop. Tracing the workflow, it starts by instantiating a template, say, buy a train ticket from Beijing to Shanghai for mom, and it patches that directly into the JSON state. That state is cloned and forked out to multiple parallel agents.
Now, while the AI agents only see visual screenshots and output physical actions like a tap, a type, or a swipe, the system calculates a programmatic state diff. It checks the structured data to verify that a ticket status actually changed to created, that the route perfectly matches Beijing to Shanghai, and the passenger is indeed mom. This feeds directly into highly accurate benchmark metrics and reinforcement learning rewards.
So the absolutely crucial takeaway here is that because we can check the entire state using that JSON difference, we can definitively catch what we call unexpected side effects. Imagine an AI successfully booked that train ticket for mom, but while it was fumbling around the menus, it accidentally deleted an old, completely unrelated order. In a real app evaluated just by looking at screenshots, you would literally never know. But in MobieGym, the JSON state comparison catches that deleted order instantly and correctly penalizes the AI. Which brings us to part 4, answer sheets and benchmarking, fixing broken evaluation metrics. Now, evaluating a ticket booking is one thing, but how do we accurately score an agent when it's just trying to retrieve information? Well, MobieGym introduces something called the answer sheet protocol. When an AI gets a query task, like checking the weather or looking up a tracking number, it doesn't just output a free text response to some invisible judge. Instead, it is actively required to physically navigate to a dedicated form within the simulated interface and type its answer into a specific typed field, like a number field, a choice field, or a text box. This is a massive improvement, a real game changer, honestly, because it replaces brittle free text judging. Before this, evaluators used other AI models, vision language models or VLMs, to look at screenshots and kind of guess if the agent found the right text. And that method often failed, rejecting correct answers if they were phrased a little differently or accepting wrong answers just because they happened to contain the right keyword. The answer sheet protocol swaps out all that guesswork for absolute programmatic truth within the simulated UI. Using this super rigorous setup, researchers put 9 top AI agents to the test. And the results? Honestly, pretty fascinating. Overall success rates were all over the map, ranging from just 9.4% up to 58.8%. There was a really clear stratification across difficulty levels, too. While some of the top proprietary models could handle simple tasks, almost all the open source models completely failed when things got complex and required multiple steps. What this proves is that the benchmark isn't even close to being maxed out. There is plenty of headroom for future AI models to grow and learn. All right, on to part 5, sim-to-real transfer, which is basically the real-world proof. But here's the million-dollar question. Does an AI trained in this digital matrix actually know how to use a real physical phone? Well, the data absolutely says yes. When comparing a base model's performance to a model trained strictly inside the MobieGym simulator, the performance gains are just massive. And even more importantly, when that newly trained model is taken out of the simulator and tested on a real-world smartphone, its success rates closely match its simulated performance across the board. To put a specific number on it, the data shows a stunning 95.1% retention rate. That means 95.1% of the performance gains that the AI achieved while practicing inside the browser-based simulation successfully carried over when the AI was tested on a real-world physical device. It learned genuine, highly transferable navigation skills, not just how to game the simulator. It's pretty amazing. The trained model even learned the underlying logic of the apps. For example, during a real device test where the AI had to create a post on Reddit, the selected community suddenly required a flare tag before the post button would activate. The base AI model completely failed. It just kept repeatedly clicking a grayed out disabled button. But the AI trained in MobieGym, it actually stopped, identified the missing flare requirement, added the flare, and successfully completed the task. It generalized its understanding of UI mechanics to overcome an unexpected real-world hurdle. And finally, part 6, the future of AI training democratizing mobile agents. This level of scalable, completely verifiable training, it represents a profound shift for the future of AI. Because MobieGym runs so efficiently right in a browser and uses deterministic JSON states, we now have a low-cost, consequence-free playground. It entirely democratizes research. We can test an AI's safety alignment to ensure it flat-out refuses malicious commands without risking real accounts. We can systematically test its robustness against annoying, unexpected pop-ups. We can run massive, low-cost reinforcement learning without needing to rent thousands of physical devices. And we can synthesize perfect step-by-step training data on demand. Which leaves us with this final thought for today's explainer. Researchers have basically built the ultimate digital dojo. They've proven that an AI can safely practice inside a browser, learn really complex interactions, and then seamlessly apply those skills to your physical smartphone. So, if the bottleneck of training is finally broken, what tedious part of your digital life will be automated next? Thanks for learning with us, and we'll catch you on the next explainer.